모스트 포던 팟캐스트.
All right. Welcome to another episode of the Most Podern podcast. Today we have with us Jared, who is gonna have a very long intro. So if you want to say hi first, then we can get into it.
Oh, okay. Hi, everyone. I'm Jared.
Also here with Minku.
Hello.
So Jared is a computational product manager at Walter P. Moore, a global engineering firm with offices around the world. He is a licensed architect with a BArch from CMU and a master's in design studies with a focus on computation and robotics from the Harvard Graduate School of Design. Jared has deep experience in parametric design, robotics, and construction technology. He's worked at places like Massaro, BuroHappold, and WeWork, and has previously taught seminars on BIM and computational design at Columbia's GSAPP. He's also the author of the EC3 Python wrapper, an open source Python package that makes it easier for Python developers to work with Building Transparency EC3 API. Welcome, Jared.
Thank you. Excited to be on the podcast. I'm a big fan of the podcast, and you guys have probably the best name for a podcast that I've seen.
Thank you.
Much appreciated. So, I mean, as we just went through, you do have an incredible background across architecture, engineering, design, and technology. But as we know, this season is going to be about sustainability. So where does sustainability fit in for you?
Yeah, I mean, for me, I think there's kind of like the personal interest and then like a professional interest. Like on a personal level, I've always just been kind of a nature nerd and always been into outdoors and hiking and that kind of thing. And so I've always had a deep kind of like interest and respect for the natural environment. And on a professional level, I think it's kind of come very organically, somewhat like not really planned, but just kind of happened to a certain degree. A lot of it from like kind of entered it through the lens of like computational design. And so I think computational design, one of like the main use cases for it, or like the most applicable use cases in the real world, is really kind of how you bridge the gap between what's in a designer's head and how you build something. And so even from like early on, when I first my first time I used Grasshopper was like when I was in undergrad, and Grasshopper is pretty new, and like we had just built like a digital fabrication lab at my school, and it was like, okay, how do I start using these machines, and like how do I work with these machines? And so it was just like, there's this tool Grasshopper, and I can create some like G code from that, and that was kind of like my first introduction to it. And so it was very much about like this, like bridging the gap between design and making something. And then even as I kind of found applications in practice, a lot of it was in that similar vein, where like, for example, at WeWork, I was involved a lot in kind of the millwork and how we kind of connect the dots between our supply chains that we were building with the people that were supplying, the laminates and the plywood and all that kind of thing, and then like the people that were fabricating it and the design teams. And so a lot of that kind of like came down to, you start thinking about material use. At a small scale as a student, you're thinking about like, okay, how do I like, pack these things really tightly so I don't have to buy as many sheets of plywood because I don't have money because I'm a student. And it's kind of the same thing when you're like in professional, if it's just scaled up really big, right? You're like, okay, like in the case of like WeWork, it was like, okay, we're doing a pantry. If I make the cabinet 39 inches instead of 40 inches tall, we can save 2 sheets of plywood per pantry. Multiply that by 1,000 or 2,000 pantries or something. Now we're talking like real, material savings, and a lot of that is obviously driven by cost and not so much from, you're not necessarily thinking sustainability first, but those things kind of tend to go hand in hand a lot. Not always, but sometimes they do. I think in the case of like materials, material usage, they often do go hand in hand, where you're kind of trying to reduce, you're trying to be more efficient with your materials and that kind of thing. Same thing could be said for like even, now at my role in Walter P. Moore, where a lot of times we're doing these large steel structures or concrete structures. You're designing, a system that's going to support some sort of facade panel. You want to use as, the least amount of steel that you can get away with in order to, actually support that. You don't want to have excess material. You want to be efficient with it. And so a lot of times when I'm building these tools, it's a lot of coming at it from that perspective of like, okay, there's ways we can do this that are simpler, but like we want to be efficient with the materials. And so we can use computational design as a way for doing that. So I think that's kind of part of how I got into it from coming at it from the angle of computational design.
So I guess from a tooling standpoint, like, would you say that the computational design tools are like an augmentation to the designer's abilities? Like maybe as an engineer or as a designer, I might not have the capacity to do all of these calculations or run all these optimizations, but some design goal that I do have is what you said, like more optimal use of materials, using less materials. And I guess especially in a sustainability standpoint, the less you use, right, the less you're wasting.
Yeah, I mean, I think for sure it's definitely like, I think, augmenting is definitely one of the big things I think it does. And then from that standpoint, it augments, but it also opens up possibilities. You can, once you realize what you're able to do, you're like, oh, we can do all these other cool things with this. And I think a lot of the things related to kind of embodied carbon tracking and things like that I'm sure we'll get into, a lot of that was something where it wasn't necessarily, it didn't start as like an augmentation thing, but it was like, oh, we can track all these things because we're already like doing these things with the computational design. And so I think there's kind of both ends where it's like helping you get to something that you were already gonna do, but then also opening up opportunities.
So speaking of which, what is embodied carbon? I mean, for me as a developer, it's sort of a jargon. Like I think many people use it without exactly knowing what it is. We know that it's bad, and we know that we want to lower it by using some alternative materials to concrete or steel. Like that's why timbers are getting a lot of interest. So could you tell us from your standpoint, what is embodied carbon?
Yeah. So kind of, I guess the literal answer to that in terms of the measurement that's used often is called the global warming potential is kind of the metric. And what that is the kilograms of CO2 equivalent, which what that really means is like when you hear that equivalent, it could be like, that doesn't necessarily mean it's just CO2 that it's measuring. It's measuring like, methane and other things that have like a ratio that is equal to, I forget what the ratio, like 12 units of CO2 is the same as 1 unit of methane or something like that. Don't quote me on that, but you get the idea where it's like equivalence. So that's like the literal metric of it. But then there's, I guess, the Carbon Leadership Forum, which is kind of one of the main, I would say, like nonprofit organization that kind of has really done a really good job at raising awareness and putting out a lot of great documentation and resources for people in the building industry looking at embodied carbon. Their definition, kind of pull up here, is it refers to the greenhouse gas emissions generated by the manufacturing, transportation, installation, maintenance, and disposal of construction materials used in buildings, roads, and other infrastructure. So I think that's like a pretty good, somewhat concise way of thinking about it. And I guess, the other kind of thing to mention is it's not what it's not, which is operational carbon. So within the building industry, we're usually looking at either embodied carbon or operational carbon. So operational carbon is the energy, the measurement of like, the carbon and the energy that's going into the operation of the building. So the heating, the electrical, that kind of thing.
So I guess from your standpoint, like embodied carbon is a lot of, I guess, what you deal with, what folks who do buildings care about. But like, how do you actually go about doing this calculation? Like, say I have a design, how do I know?
Yeah, so the calculation itself is actually pretty simple. It's the quantity of material, which like we should already know for building something. Like we need to know the quantities at some point, multiplied by the impact of the material. So that one, the material impacts are a little bit harder to get at. but they're not that, like, there are resources out there to find them, databases that have kind of specific product impacts, and then there's baselines. So I mentioned the Carbon Leadership Forum, for example. They put out reports every year or two that kind of have the North America, like baselines. Then different industry organizations put out their own baselines. So like the National Ready Mix Association, like for concrete, like they put out regional baselines every couple of years as well, which is kind of where Carbon Leadership Forum will grab. So the Carbon Leadership Forum kind of like consolidates a lot of the baseline values that are out there, so people can have kind of a reference to use, whether it's kind of a carpet or steel or concrete, whatever it is. There's some baseline numbers that people can use and say, okay, I have this tonnage or this cubic yardage or this square foot of this material, multiply by that impact, and then that's kind of how you would arrive at your embodied carbon number.
In the beginning of the design process, you probably have a very rough understanding of what you're using, and you need those numbers to kind of translate into the carbon calculations. So you generally probably don't have a really great idea. But I guess at what stage does embodied carbon enter the conversation? And when you're doing these early calculations and you need to make adjustments, like what are some of the things that you can do?
Yeah, so I think you kind of hit on the key point there, where early on in the process where you have the most opportunity for impact is really when you have the least amount of data. And so that kind of creates its own problem. But that doesn't mean you like hold off on embodied carbon discussions, because that's, like I said, that's when you have the most opportunity for impact. So I think one of the ways in which we, as internally in our company and the industry as a whole, is looking at this is like, how do we use past building data in order to get us a good starting point in terms of like approximating things? And it's not like a simple formula. Like I think you really have to look at real building data, because buildings are messy and like there's they vary from building to building, and even if you find one or two similar buildings, it's not necessarily going to be indicative, especially if it's in a different region or whatever it is, like or like the materials are made on a different energy grid. Like it's very difficult to kind of like compare to just like a small sample size of building. So you really need like a large data set that is kind of where you understand the data and where that's coming from. So so I think these discussions need to be happening very early on, and so you need to kind of be okay with the uncertainties and like learn how to handle those. And then like throughout the process, as you're getting more and more information and you're developing like your models and you're picking out materials, then you kind of like are reducing your uncertainty factor and getting a better sense of your numbers and what you can hit and what's achievable. So yeah, the answer is like you don't wait until the data is there to start. You just start and learn how to handle the uncertainty, and it's a challenge. It's not easy. That's kind of, I think, what we are as an industry are kind of trying to wrap our head around.
Is there like a rule of thumb typically that you recommend to the owner side when it comes to embodied carbon? Like where do we start?
I mean, I think what we would do is like look at our building data that we have, like a database of our own buildings that we've looked at. There's other open source tools out there that like have their own data, but like you generally there are some, like based on the building typology, there's some rough numbers. So one of the there's a number of like sort of initiatives out in both like architecture, mechanical engineering, and structural engineering around embodied carbon. So the one in structural engineering is called SE 2050, for example. And so they have like, one of the things that they've been doing is collecting data and like kind of grouping things into different building typologies, so that you can come up with like a rough range of like, okay, I'm doing a public assembly arena or something project, or I'm doing a commercial office space. Here's like a rough range, and that's based on part of what that is different structural engineers have signed up to commit their data and report every year to that database, basically contribute to that, and so that becomes a shared resource for the industry. So that's like one thing that we're starting to see as kind of a useful metric. But really, I think a lot of it isn't really the owner's not coming to us and saying like, what is my embodied carbon value per square foot? Because even if we told them, they wouldn't know what that means. So like, really, like I think our opportunity to educate them is on like, here are the design decisions that you can do that will benefit you the most. And I think that's kind of really where the value is it's taking that data and like putting it through you as the designer and like understanding how to communicate that to your client in a meaningful way. And then that usually isn't just like, a bunch of numbers per square foot. That's going to be more like, oh, if you did this instead of this with your foundations, or if you, instead of putting, instead of covering your whole roof in solar panels, what if you took some of that money and put it toward this? Like that might, over the life of the building, might actually be better. So there's discussions like that I think are like useful early on.
Wow, I think you touched on a very interesting point for me, because in terms of like energy performance, there are policies out there that actually requires developers to meet a certain R score, R level. So that's why, like for my projects, I just commit to Passive House because I know that will be more than the requirement. But are there anything? I don't know if there's anything out there that does a similar, that has a similar type of restrictions or requirement for carbon embodied carbon savings, for example. Where do you think? Why do you think the owners get motivated to do these type of studies?
Yeah, so I guess there's a couple questions in there. Like from the policy standpoint, I think like with the R squared example, like a lot of the requirements that are out there now are related to like operational carbon. And a lot of that is due to us having better data on operational. Like we've been looking at, operational carbon has been kind of something that we've been looking at as an industry for like almost 50 years, depending on how you think about it. But we have energy bills that come in and out. That data is like very, I know how much electricity I used last month. Like that's a very clear cut thing. And so we have really good data on that. And so it's enabled us to make good policies around that. We're kind of like with the embodied carbon side of things, we're playing catch up a little bit. We're at the stage now where we're like still trying to get that good data, and policies are starting to come out. And they're starting to figure it out, but we're like just at the beginning, like the very early phases of that, I would say. And so there are a lot of the policies are very localized now. So like, or like state by state or region by region, like I know like in New York, the Port Authority has certain policies around it. Like California is obviously usually like kind of in the lead with a lot of these policies. New York State has a few different states have put out policies now, and a lot of those policies are kind of more around requirements for what are called environmental product declarations, or EPDs. So if I'm building a building and I'm using these 10 different concrete mixes, it's going to be required for me to get EPDs from all of the concrete mix suppliers on that job, and I have to make sure that the global warming potential of those mixes is within a certain percentage of the baseline, like the regional baseline. So that's kind of an example of how these policies are starting to come into the industry, is kind of like based on these products and based on the regional baselines, where are you? Like you have to be within a certain threshold of that. So that's kind of where we're seeing that kind of thing.
So I want to ask, I guess, your role is a computational designer, and we talked a little bit before we started about how, I guess, Walter P. Moore is starting to formalize the function within the company. Can you tell us a little bit about how your role works with maybe the sustainability practice at Walter P. Moore, and how do you guys interact with project teams to kind of pull everything together?
Yeah, so I think, as a computational designer with kind of an interest and focus on materials and energy, one of the things that I've put a lot of time into is building tools that communicate to the design teams, how much embodied carbon their projects are using, and how you can start to get quantities and things like that early on. And so we don't actually have like I mean, we have a small handful of people that are like devoted to sustainability things, but it's really kind of expected that it's on like the project teams and project managers are the ones that are having these conversations with clients. And so we don't necessarily have it. We will do occasionally like perform like a life cycle assessment, which is kind of like a report on kind of the energy and materials that are going into a building. We might do that as kind of its own service occasionally, but we don't necessarily have like a sustainability as a service at this point, at least. A lot of it is really ingrained in like the way we see it is this is just kind of how business needs to do on every project. Every project's got to track their carbon. We need to do what we can to educate the clients and promote having these conversations on the jobs. And so a lot of kind of my role as a computational designer is how do I empower the teams to do that and make it so that they can come to the table with the data and not necessarily present the data exactly how it is, but like have the data in their back pocket to say, okay, I know if we do this, this, and this, then here's like where we'll be versus what we currently have, or that kind of thing.
That's pretty amazing that it's like standard practice kind of on every project. I guess, is it something that's standardized? Like even if you guys don't get asked by your clients about this, that every project manager is kind of like already running this in the background?
To a certain extent, yeah, because like I said, the formula for embodied carbon is really just quantity time impact, and we need our quantities anyway. And so I've built the tool, and it's funny, like we have a tool that I built internally that all it really does is it takes your quantity and like if you don't give it specific product like impacts, it'll kind of just make some assumptions for you. But you kind of upload your model or whatever data that you have at that time, and it'll kind of give you some rough numbers. And people have just been using it sometimes just to get their quantities. And like the embodied carbon data is kind of coming there almost, it's almost like a, Trojan horse kind of thing where it's like, we needed our quantities, but hey, by the way, it's, we have this other data, so you're going to get it. So like, in a way, it's kind of snuck its way into some projects, even though they're not really, thinking about it very directly, but that information's all there for us to leverage.
I'm realizing we haven't really talked about what the tools you build actually do. I guess can you give us a little pitch about, what are some of the products you build internally and how they're used?
Yeah, sure. So within our computational design group as a whole, I guess we do kind of a mix of some standalone applications, some web-based applications, plugins, so like things for like Revit and Grasshopper and things like that. So like there's a pretty wide gamut of tools that we will build for some of the things related specifically to embodied carbon. A lot of that has been kind of built on a workflow that kind of basically a workflow where people can map materials to their usages, what we would call, like when I say usages, you could think about it like, okay, this is a spread footing, or this is a foundation wall, and they can map materials to that in a separate interface from Revit, because Revit's really bad at like mapping materials and doing that kind of thing. So even though Revit's good at documentation and is a database, it's not like a very easy database to work with. And so we kind of have created separate interfaces for allowing the teams to put in material data and work out and like have these discussions around materials outside of the model before things are, you don't have to wait to have like a Revit model to start having these discussions. And so part of it is kind of that. And then there's we have internally kind of our own schema that was historically built around interoperability. So because structural engineers use so many different software, so there's half a dozen or more different structural analysis software that we use. There's Revit, there's Rhino, there's Tekla. So there's all these different software. So we historically have needed to kind of have our own schema that we've developed, which is really like, just like when I say that, it's just kind of a JSON file that allows you to get between from software to software without having to maintain multiple models. And so we have kind of built on top of that since we already had that for interoperability purposes, we now just kind of have been building like viewers and things like that. And like, so one of the things is basically kind of an embodied carbon viewer. You can think about it like that. But it's a little bit more than that, because it allows you to like input like placeholders, for example. So like if I don't have a model fully done, or if it's half done or whatever, I don't have to wait until it's done to start getting all my quantities and embodied carbon data. So like I can upload what I have, and then I can say like, oh yeah, by the way, like use this spreadsheet, or directly plug in my other numbers that I don't know, but I have like a rough idea of, and then it'll kind of help the users see that and visualize it, and kind of make, just all sorts of data visualizations that then they can kind of help communicate to the clients on their projects.
Wow. So you're customizing software and plugins for your company, and those sounds like it's very effective and makes the workflow much efficient. Do they have any plans to make it not publicly, but like create a software product out of it?
We've talked about that a little bit internally, and there's aspects of it that we want to make available directly to the clients. I think there's a lot of products out there already that I've seen companies come out with, and the problem with that a lot of times is it just becomes it's such like a burden to maintain internally alone, and then to maintain something externally, you really need to like at that point hire like a full software development team to, if you're like really serious about something being a product that you're going to put out in the world that people are going to use. I think that's part of the issue. The other part is like, reality is that we have our competitors aren't going to want to use something that we put out, and we're not going to want to use something that our competitors put out. So like there's a little bit of that, and that's not specific to embodied carbon and sustainability tools. That's just in general. I think in the industry, there's been very few success stories, I think, about architecture and engineering firms externalizing their tools to to sell and actually like monetize. Like I really think you have to be smart about how you spin something off into a separate company almost, if you're really going to do that well.
Yeah, I want to watch back to I think there's something important that you like briefly touched on, is the notion of interoperability, right? Like you use a ton of software, and I think as we're used to in the industry, like all the software is closed. It's very hard to kind of import, export data, to transfer models from one software to another. And you talked about how Walter P. Moore developed your own schema, which is a fancy word for how you structure data. And you're using JSON, which for those of you who I guess don't know, is an open kind of structured text format for data. And I guess where I'm getting to is, your EC3 Python wrapper is also open source, right? So like, I guess, how do you balance this commitment to openness and interoperability? And, Minku mentioned, potentially selling the software, but here you are almost giving out for free, right? So what's the motivation behind how you make these decisions?
Yeah, so I guess, so you mentioned like the EC3 Python wrapper. So that was, just to be clear, that was like a side project of my own that I had kind of done. And the reason for doing that kind of open source as opposed to maybe like pitching to try to do that in-house is I wanted to make sure that that was kind of a resource that I want other people to build on top of it. And so if they see that it's coming from a company that's going to immediately kind of like make people a little bit more hesitant. And so I think it was important for me that like I want other people to use this and tell me, what they think. And yes, I can leverage this for my own work internally, like at Walter P. Moore, my day-to-day. And like, so to me, like, it's kind of a win-win for the company, because like I'm building this stuff out on my own time, but we're also being able to leverage it because I'm the author, and so I know how to use it really well. So like I think from that respect, it's kind of it's beneficial for the company and for the project, because then I think other people will be more likely to engage with it in the long term.
What's EC3?
So EC3 stands for Embodied Carbon and Construction Calculator. Basically, so there's a nonprofit organization called Building Transparency that have built EC3, and basically what it is, it's kind of a database. It's a free and open source database of environmental product declarations. So, manufacturers or concrete plants or whatever that are coming up with mixes, or whoever, not just concrete, it's all building materials. But they can upload their EPDs to the database, and then designers can go and find that and use that for getting their data and putting together LCAs and all that kind of thing. And so they also have an API that, because building data is so messy and there's so many different like properties and stuff, the API and the database is very difficult to work with in a way. It's just kind of the nature of the beast. And so part of what I wanted to do was with this project was make it a little bit simpler. Also, as someone who is kind of an amateur developer who likes to use Python, I wanted it to be in Python, and so I kind of built a Python wrapper around it to help make it a little bit easier to work with and analyze the data.
It's a fun like nesting doll situation where you have like a really complex API that you then wrap, and then you use your own wrapper to build your own tools, and then people use your tools to then do their work. So I guess part of it is like in your work, and I guess the folks that you collaborate with, like how do you decide when to segment something out into a common tool that you guys use as developers, and when do you just go heads down, focus, and just build that one thing?
Yeah, I mean, I think we always want to try to modularize things as much as we can. There is like, I mean, the types of projects that we do at Walter B. Moore tend to be very like one-off, like, large stadiums or airports that are like very unique projects that there's not a ton of repetition of that. And so like there are definitely times when it's like, okay, I'm just going to make this like grasshopper definition or this Python script that's like going to be used on this project and this project alone, and that's fine. And I accept that that's kind of like, I'm not trying to make it modularized for other stuff. But then there's bits and pieces that you can always pull out and try to make that could be shared between tools and projects and things like that. So it is definitely kind of like something that comes with experience in terms of like being able to identify what pieces you can pull out and what isn't worth pulling out.
So I guess despite all the tooling, sustainability, I feel like is still a pretty big challenge. And I think from your standpoint, right, like someone who's been building tooling, someone who's worked with people that you've supported in doing a lot of these calculations and kind of at this forefront of building these large projects with these tools in mind, like what challenges do you see that are coming in maybe the next 5 to 10 years, and how can maybe we as people who build technology better support the folks that are going to be in the thick of it?
I think a lot of it is like making it easy for people to present the data that we know, and like I guess, well, before even that step is it's collecting the data in a way that we can work with it, which is really difficult to do. That's like, especially with embodied carbon. I like we kind of talked about it a little bit before about like the data around operational carbon is good now because we've been at it for like 50 years. And it's also kind of, in a way, it's easier to track because we get bills that are directly correlated to the amount of energy, whereas embodied carbon is it's much messier. And so I think that's one of the challenges that we're still wrapping our hands around in terms of trying to, get to a point where that data is easy to work with. So that's part of it. And then it's communicating to the contractors or clients and owners or whoever it is about what are meaningful things. Because a lot of times people come in with good intentions, but they might just have a false impression of like what is actually good from an embodied carbon standpoint. Like the example before, where like we heard a few times in large projects where people just want to cover their entire roof with solar panels, and it's like, hold on, like the solar panels didn't just fall out of the sky. Like there's materials and energy that's going into making them, and then like shipping them, and by the way, you're in an energy grid that is already using like mostly hydro, or once you really start to dig into the weeds, it's like
Hmm.
you realize that like even if somebody's coming to you with a good idea, or what like with good intentions, like their initial thoughts on like what is good might not be correct. And even things as simple as like density, like we always like to think that like density is good for sustainability.
Hmm.
To a certain degree, that's true, but there's also like a point where there's kind of it's not so true. If you really think about from embodied carbon standpoint, if I'm building a really tall building, um, that means I'm going to have more structure to handle larger, loads. And so it's not always the most efficient from like or the most sustainable kind of option. So there's always like these little like trade-offs and things in terms of managing what people's intentions are versus like what is really the right move to make.
Yeah, so I
Hmm.
guess part of what you're saying is like people have good intent, people come to the table with great ideas, but it's actually really hard for us to understand kind of the total impact of a building and all the decisions that kind of go with it. I guess what are some of the counterintuitive things you've learned beyond the ones you just mentioned?
I think like I mean one thing we were like plotting the embodied carbon of all of our projects, and people always kind of talk about how bad concrete is from an embodied carbon standpoint
Hmm.
because of the cement and the energy that goes into making cement. And we were looking kind of across our portfolio and actually noticed that a lot of our concrete buildings were actually like a carbon intensity level, and by carbon intensity I mean like basically like the carbon per square foot um, are actually better than steel in a lot of cases. And then I looked at some of the other like industry-wide databases, and it's the same thing. Not significantly, but like a little bit. And if you think about like, oh, now if I were to really push that level rather than just like assume concrete's bad and never use concrete, what
Hmm.
if we like pushed it a little bit and said like, oh, okay, what if we get our mix design so that like we can get like a lower embodied carbon concrete, or like how do we like remove some concrete in areas where we're putting it that maybe it doesn't need to be, like those could be valuable moves. So that's something that like came up somewhat recently that surprised me a little bit.
Yeah, even for timber, it depends on the source, and
Yeah,
yeah. So
yeah, like yeah.
yeah, for me as an owner, it's probably I'm the one who comes with a good intention, but gets surprised at the end because I always thought like, okay, like we're gonna do a timber building, it will be much better than concrete and steel without even thinking, like without even looking at it into detail. But I found out that it's all really not. It's not about just building the building, but it's about where you source those materials, how and after you build it, how does it last and how does it decompose essentially. So, like all this tracking of the life cycle itself, understanding that importance, I just thought, okay, like how is there any metric out there? Like how can I even measure this? Like how do I even know? So I guess what
Yeah.
you're saying, Jared, what is that it is a messy environment because it's so new. When do you think we'll be ready, or is it rapidly kind of being developed following the um, following the what do you call, what was the term you use after it's built, like the
Like,
Operational carbon.
operational carbon? Yeah, exactly.
yeah. I mean, like, I don't, it's, it's, it's very difficult to imagine like a point in time where it's like going to be simple.
Hmm.
But I do think we can get to like, here are key decisions or like things that we can change doing. Um, like I think a lot of it is the industry like changes. Anyone that's in the AEC industry knows that it's very slow to make changes.
Hmm.
Um, and I think a lot of that is not necessarily that because the new things that we might be proposing are technologically complex or even like complex from a manufacturing standpoint. It's just because of the risk of and like monetary risk for a contractor or owner to try something new,
Hmm.
even though that might ultimately be a better way of doing it. There's always there's just so much risk involved in the industry, and so I think that's a little bit of 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 what the issue is going to be going forward, not so much the exact, quantification of things, but like if we were to propose doing, like you said, like timber isn't new. It's been around for a while, but we're just now catching up in terms of the building codes and like these types of things. And manufacturers, like there's still like in the US, there aren't a lot of manufacturers in certain regions of the US, and so it still doesn't make sense in a lot of areas. But that's changing, but it's just going to take time for that kind of thing to change. So yeah, it's just, I don't know if it's ever gonna not be messy, but I do think there are things that can, make big impacts. Like I was on a job site a couple months back that was doing like a hybrid steel structure with CLT floor frame, and like the contractor was like, "This is the first time like my construction crew is doing this." The first day they put one bay up. The second day they had 40 bays up. Once they learned the system, it was like, "Oh, this is easy." Like, and they were like months ahead on their schedule because they didn't like, they built in so much fluff because they didn't know the system. So they were like ahead, but really that's what it takes. Like that's like the time it takes. But like I think, and yes, there's a cost premium to doing that right now, but that's not necessarily baked in. Like that cost can come down as there are more, manufacturers out there and more people realize like, oh, this actually isn't that hard. Like maybe we can, lower our installation costs for this, that kind of thing.
I don't think it's ever going to stop being messy, right? Like buildings are pretty complex endeavors. And I think you touched upon the point of data like a few times where data is the place where you can go to challenge your assumptions, to find these insights. And I think as we both know, the AEC industry is not traditionally known to be a data mature industry. Sometimes, architects probably don't even track numbers on a lot of their projects. So I guess like for Walter P. Moore, like how have you guys established a data practice? And maybe for some of the historical projects, do you guys like go back and like backfill data? And how does that process work?
Yeah, so we do occasionally, we'll go back and like we go back to like old models or whatever, or submittals, and try to kind of like reconstruct that kind of like schema that I was talking about from that, so that we have that as another data point. So that is something that we do. But yeah, I mean, a lot of it is just like trying to that's where like I think computational design comes in terms of building tools to make it easy so that the designers don't have to think too much about it. So like, a lot of the information that we need, and I think it's a little bit easier for structural engineers and architects, to be honest, because we deal with a lot fewer materials. It's primarily like steel, concrete, maybe some timber, whereas like architects have, dozens of materials and finishes and all that kind of thing to handle. So I think the data problem's a little bit easier in certain regards from the structural engineering side of things. But at the same time, like you have to like try to not get stuck trying to get like every last bit of like, I don't care so much about the GWP of a bolt. Kind of like I know that's going to be, bolts and the steel are going to be less than 1% of the structure from a GWP like embodied carbon perspective. So like you have to kind of be like pick and choose what battles you want to tackle from a data perspective. And I think that's true regardless of whether you're a structural engineer or an architect or whatever. I think there's always that's where the data helps, where like you can definitively say like, okay, these last 100 jobs that we did, we know that this product is less than 1% of the GWP. Like we don't need to go crazy counting that. Let's focus on like the big things.
That makes a ton of sense. So like by looking at the data, it helps you understand what you need to focus on and where maybe the efficiency gains. I guess the efficiency gains has the highest ROI. And I think we were talking to Brian, who and one of the things he said about his research is that in the kind of optimization you can do, there's these outside boundaries that happen because we don't have materials or we don't have things that kind of introduce a new solution to that space. So I guess for you, when you're taking a look at all of these things and you find something that's like, hey, like this is what we can improve, like who do you go to? How do you like bring people together to kind of go down that road and maybe find a new solution that you can use in new projects?
Yeah, it varies based on who the client is. So, I mean, in most cases, our client is the architect. Sometimes it's the contractor. Sometimes it's an owner.
Mm-hmm.
And so the answer will kind of depend a little bit on who you're talking with, and like sometimes it's asking the architect to like, hey, here's something that we would like you to talk about with the contractor, talk about with the owner.
Mm-hmm.
And so there's things like that. I mean, so like from a supply chain perspective, for example, like, um, a lot of like I was mentioning, certain states are now having like requirements around requiring environmental product declarations and that kind of thing. And a lot of the smaller concrete suppliers like don't have that, and like they don't know what to do when we ask them for it. And we, as a structural engineer, can come in and say like, oh, by the way, here's some resources it's not that hard to do to
Mm-hmm.
create one. Here's some resources out there that can help you. Like you have the data that you need to create an environmental product declaration, you just like don't know how to do it, and we can help you do it. So there's like things like that where we can sort of like reach into the supply chain a little bit and try to help people.
Mm-hmm.
And then there's things like, just presenting to an owner or an architect, like, hey, here's 5 different foundation options. Here's the one that's the lowest from usually usually the lowest cost and lowest GWP are matched. And when it comes to just like, quantity of material kind of thing. So there's like that kind of thing where it's like, here's some different options.
Mm-hmm.
And usually there's a clear winner in that case. Where it becomes a little bit trickier is like trying to get people to use like a new product or a
Mm-hmm.
new thing that like isn't tested at a certain scale. And that's when like, the cost and the embodied carbon things might not necessarily be aligned.
Mm-hmm.
But you have to, in those cases, you have to find like the right client who's willing to go along that journey and, uh, take on that risk.
So we talk a lot about risk aversion, which, as we know, we're a very risk averse industry. But I guess from your standpoint, like, is these new policies, requirements, even the new data about like embodied carbon, operational carbon, kind of greenhouse gas emissions, like, has it been kind of a forcing function for people to try new things to maybe take a little bit more risk in what they do?
Sorry, you say a forcing function?
Yeah, yeah. So
Okay.
like, if they wouldn't do this unless they needed to adhere to some
Yeah,
sort of
yeah.
new requirement.
Yeah, no, I think it has been to a certain degree. Like, and even like a lot of the policies, to be quite frank, like the requirements are ridiculously easy to like hit. Like the New York State one that came out recently, it's like you need to be within like you can't be like worse than 50% above the baseline. So it's basically saying like, you can get a D and that's okay. Like, it's not that hard to hit, but it's an important step to like force people to get the process of
Hmm.
like, okay, let's like learn how to make sure that all the suppliers have the data that we need to start tracking these things. And then in the future, the policies will look, become more and more strict once the industry has kind of like gotten the hang of how to do certain, tracking things.
Yeah, similar to the energy code.
Yeah. Yeah. Like I think with like lead, for example, is the same way. Like I think there's a lot of flaws with lead, and I think most people in the sustainability world like to kind of like nitpick at it. And but I think where it has been good is like forcing suppliers and manufacturers to produce things that will help, that are good. So there is like a benefit from that, regardless of like the flaws that there are in some of these kind of like building rating systems.
Maybe as we wrap, as someone who's like very passionate about this field, very passionate about what you do, what is something that maybe you're optimistic about that we can look forward to in the next 5 to 10 years on sustainability in the built environment?
I mean, like I think just uh, I mean the the fact that the discussion about embodied carbon is like such a hot topic now, I think that to me is like sort of promising, and that like people are actually caring about this. And it's taken a while. I mean, you really have to go back. Like, it wasn't like beyond like 10 years ago. It was very rarely talked about. But then like little things started happening. Things like tools like Tally LCA came out, and that like helps for tracking, and that was also around, I think, that same time when like LEED started talking a little bit about embodied carbon and material. And so there's like things that were happening around like 10 years ago, and like now we're at the point where everybody's talking about it. And so like I kind of am thinking like, okay, in like 10 years from now, like maybe we're gonna have like a really good like handle on tracking embodied carbon policy, and like tracking things a lot better than we are right now, and we'll have better like baselines and things like that. So that part I think is promising, and it's something that I'm optimistic about.
Yeah. Thanks, Jared. For me, this was a fascinating discussion because in my mind, computational designers from the form giving side are parametrics and like designing weird forms. And you just introduced a whole nother perspective that, using computational design techniques to actually work with an engineering firm to customize these tools for sustainability is just awesome. So thank you so much.
I'm sure Jared can make weird shapes for you too, but he
Yeah,
just
I'm
chooses.
sure, but
I do that too.
He just chooses to use his power for good,
Yeah. That's why I'm saying it's fascinating. Like I was hoping to have it apply to something else than just like exotic forms.
So,
Yeah,
well, Jared, I guess if people want to find out more about EC3 Python Wrapper or the work that you do, where can they find you?
You can find me on LinkedIn. I started a little blog called matterflows.com that people can, there's some tutorials and things on there about the EC3 wrapper, as well as just some random streams of thought that I sometimes have. So I'll try to be posting more there in the next year. But yeah, those are a couple spots.
Awesome. Well, thank you both. And thank you, our listeners. This has been another episode of the Most Podern podcast. If you haven't already, please like and subscribe wherever you're listening. Thank you.
Thanks, Jared.
Yeah.
Thanks, guys.
Most Podern.
Most Podern.
Most Podern.
Most Podern. 모스트 포던 팟캐스트